So gas evolution, reactions, they follow the double displacement scheme. It's what it sounds like. It evolves a gas or produces a gas. So instead of producing a solid like a precipitation reaction or producing a liquid water like the acid-base reaction, it's going to produce a gas instead. Now, when we think of gas evolution reactions, an example, let's say we have sulfuric acid and we mix it with lithium sulfide. Now, if we were just to look at this, we might think this is a precipitation reaction, but we'd have to recognize that, okay, when we go ahead and switch, and I'll show you guys how we recognize it. We're gonna switch our cations. So can anyone predict what my products are gonna be? Because it's gonna follow the double displacement scheme. So remember, the only thing we're switching is the hydrogen and the lithium. So what's the first product or one of the products?
H2 sulfur.
Okay, so you're saying
H2S.
H2S like this? This is called hydrogen sulfide?
Yes.
All right, and what's the other one gonna be?
Lithium to SO4.
All right, so the other one is lithium sulfate. Now, these just happen to both have the same subscript, but just remember when we're switching our cations, we have to make new formulas. So the hydrogen goes with the sulfur, hydrogen's +1, sulfur still 2-, so that's why it's gonna have a 2 right here. Lithium goes with the sulfate, sulfate is SO4 2-, that's why it has a 2 right here as well. Now, after we go ahead and switch them and come up with our products, we'd have to recognize that hydrogen sulfide, this H2S, actually is a gas. And this is an aqueous solution. And this is how we recognize that it is a gas evolution reaction, just because it forms this gas right here. Now, once again, this is gonna be, we gotta make sure it's balanced. 2 hydrogens, 1 sulfate, 2 lithiums, 1 sulfur, 1 sulfur. So it looks balanced. We have to we can go ahead and say this is the molecular equation. And if I write the complete ionic equation for the following, I'm gonna go through the same steps. If it has an AQ next to it, right here, and right here, I can break it up into its ions. And when I break it apart, I have to make sure I say how many of each ion I have. So for instance, with the sulfuric acid, when it breaks apart, it forms 2 hydrogen ions plus 1 sulfate ion. So it's important to put how many of each ion and the correct charge of the ion. You're actually supposed to put AQ under each one of these, but I usually run out of room when I do that. So I'm not gonna trip if you don't put the AQ, but you need to make sure you put the correct charge and the correct number of each ion. Plus 2 lithium ions plus 1 sulfur ion or sulfide ion. It reacts to form this gas. This is not an AQ next to it. It actually, this gas comes together, it bubbles out of the solution in a gas. So I'm going to leave that together. And then these other ions are just sitting around in the solution. And once again, guys, if I want to write the net ionic equation, what do you guys think it will be?
So we're taking the SO4 out because those are the spectators, right?
right?
Taking 2H plus and plus S 2S.
Okay, so we're saying we definitely take the spectator ions out, which is the sulfate, because there's one on each side. And then there's also 2 lithiums on each side. So those are my spectator ions. I'll just circle them in pink. These are spectators. They're not doing anything. They're just sitting there. So the only reaction that's occurring when I mix these 2 substances together is that my 2 hydrogen ions are reacting with sulfur 2 minus ions, and they are forming a gaseous hydrogen sulfide.
I'm confused.
Be more specific, what you confused on?
Like with NIE, like how did you, the 2 ions, I don't understand how you get the third problem.
So you see the gas, you see, make sure everything that has an AQ next to it, we broke apart into its ions. Do you see that part?
Right.
And then we did not break this gas apart because that was a product. That's a product that was formed. This isn't really a product. These are just ions that are just floating around. So when I say the net ionic, it's just saying what's the overall, it's kind of like, when you get your paycheck and you got your gross pay and then they take out your taxes and all that stuff and then what you're left over with. This is kind of what we're left over with, and this is the only reaction that's occurring. So basically, we look to the gas and we say, okay, well, what made up this gas? The 2 hydrogens came together with the 1 sulfide ion and formed hydrogen sulfide.
Okay, thank you. I get it.
Okay. Any other questions?
So sulfur has like 2 negative charge. So do we consider it as a 2 sulfur or no?
Oh, no. So it's only, see, we have 2 hydrogens and this subscript takes care of that 2 hydrogens. And this is a 2 minus, and sulfur is 2 minus because if we look at our periodic table, let me grab my periodic table. Remember, if we look at our periodic table, sulfur is in the same group as oxygen. And when it turns into an ion, it forms a 2 minus charge. So that's all I'm writing here is that 2 minus for sulfur when it turns into an ion. When it comes together, when these 2 come together and we write the formula for it, we're saying, oh, okay, I need 2 hydrogens for every 1 sulfur for this to balance out. So if I write the formula, this is how I write the formula.
Okay, I got it.
Okay, good. Any other questions? All right, so the gas evolution ones, they get a little tricky. Let me give you another example of the gas evolution ones. This one's straightforward. You just have to make sure you recognize that hydrogen sulfide. I'll give you a little table of the different compounds that are going to form the gas. But another example, let's do another example. Let's say we have hydrochloric acid. And this time we're adding it to sodium bicarbonate. So we have hydrochloric acid and adding it to sodium bicarbonate. So a lot of times when these carbonates or these sulfates, these sulfites or hydroxides are mixed with acids, they're going to form gases. So I'll give you.
Sodium bicarbonate is polyatomic ions, right?
Yep, so the bicarbonate part is just this HCO3 is the polyatomic ion. So when we go to form our products, remember the hydrogen and the sodium are going to switch places. So what do you guys think our product is going to be? If we switch places.
HCO3 H2CO3.
So you're saying the hydrogen's gonna go with the bicarbonate, which is the HCO3. So we can basically say that that's H2CO3. And then plus, what's the other product?
NaCl.
We say the other product is gonna be the sodium and the chlorine go together. We have NaCl. Now, what we'd have to recognize in this case is that this is called by carbonic acid. Carbonic acid is unstable and immediately breaks down to water and carbon dioxide. So because it's an unstable product, what really happens is water and carbon dioxide form and then plus NaCl. So I'm still gonna say this plus sodium chloride. This is aqueous. So this is our molecular equation. And when we go to
I'm
write,
sorry, why do we put CO2?
this is just, we'd have to recognize that this breaks down to water and CO2. Basically, they equal each other. We can say this is an unstable product. The carbonic acid is unstable and it immediately breaks apart into water and carbon dioxide.
Okay,
So after it breaks apart, this is basically the balanced equation that we would have. If we want to write our complete ionic equation, we're still doing the same thing. If it has an AQ next to it, we break it apart. So we're going to break this apart. We're going to break this apart. We're going to break this apart. So when we write the complete ionic, it looks like hydrogen ions plus chloride ions plus sodium ions plus bicarbonate ions react to form liquid water plus carbon dioxide gas plus sodium ions plus chloride ions. Now, can
We are
anyone
going to do nothing to do with the H2O, right?
say it again?
We are not going to do anything with H2O, right?
With the H2O or what else?
The H2O.
The H2O, and we're not going to do anything with the carbon dioxide because this is a liquid, this is a gas. We only break apart something that says AQ. And remember, all aqueous means is that it broke apart in water or dissolved in water. So in this case, our spectator ions are going to be chlorines on both sides, sodiums on both sides. And the only reaction that's occurring, our net ionic equation, is hydrogen ions came together with bicarbonate ions to form water, liquid water, and carbon dioxide gas. So let me give you the table of the different types of unstable products that you'd have to know that break down into gases. So I'm going to say unstable. And then I'm going to say the products that they form. I'll write this in purple. All right, so carbonic acid, H2CO3. That's what we just had right here, H2CO3. Anytime we see that, we have to know that that's going to break down to liquid water and carbon dioxide gas. Anytime we see sulfurous acid, H2SO3, it's going to break down to water, liquid water, and SO2, sulfur dioxide gas. If we have ammonium hydroxide, it's going to break down to liquid water and ammonia, which is a gas. And then finally, we'd have to recognize that if we have H2S, it's just a gas, which is hydrogen sulfide. So these are the different types of gas evolution equations you're going to come across. Basically, when you do your double displacement scheme, so let's look at the example right here. When we did the double displacement, we switched our cations, and when we switched them, the Na went with the Cl, the H went with this HCO3 to form H2CO3. We'd have to recognize that H2CO3 really means water plus carbon dioxide. And then we'd say plus our other salt. So if we formed H2SO3, we'd have to write instead in its place, water plus sulfur dioxide plus whatever other salt it would form. Does this make sense to you guys? And I have a lot of...
Another problem.
Yeah, we can. Let me grab one. Let me just open the book and grab one. Okay. All right, so let's do another one. Let's say we have, for example, we have acetic acid, which is HC2H3O2, like this. We mix it with sodium bicarbonate. Oh, let's do one where we don't do the bicarbonate again. Let's do one with one of the other examples. Let's say we have hydrochloric acid, and we mix it with sodium. Let's say we mix it with the bisulfate, HSO3. All right, let's say it looks like this. When we go through our steps, what do you guys think the products are going to be if we just follow the double displacement scheme? Somebody besides Pawan, tell me what you think the products are going to be.
I have sodium chloride.
Okay, we see that sodium chloride is one of our products. What's the other product?
So H2O-SO2?
You mean to say H2SO3?
Yes. Yes, that one.
Okay, but do you see what I'm saying? We're switching this one and this one. So we put the H over here, so we end up saying H2SO3 plus sodium chloride.
Yes, exactly.
Okay, does everyone at least see how I got these two products? We see that
Yeah.
part? All right. So once I get this product, I gotta know, okay, I have this H2SO3, which is a sulfide or a bisulfite. I have to know that that really equals water plus sulfur dioxide gas. So instead of this being my product, it's really going to be H2O plus sulfur dioxide gas plus sodium chloride, which is going to be aqueous. Does that make sense, guys? We just followed this table up here. We saw we had H2SO3. Instead of writing that out, I wrote this instead. Sandra, does that help you?
Yes, that's it.
Okay, so in this case, once I figure out what my products are, I can still write my complete ionic, net ionic. Complete ionic says, if it's got an AQ next to it, this should say AQ. Sorry, I didn't mean. If it's got an AQ next to it, so in this case, it's going to be AQ, AQ. Those three have AQs next to it. I got to break them apart into their ions like this. So that means I have hydrogen ion plus chloride ions plus sodium plus this bisulfite, HSO3, react to form. I do not break apart the liquid or the gas. If there was a solid here, I wouldn't break apart the solid either. I'm only breaking apart things that have AQ next to it. So H2O stays together. Sulfur dioxide stays together. But my sodium breaks apart. And remember, these are gas evolution reactions because they form a gas. Anything that forms a gas, we're going to call it a gas evolution reaction. Once we do this, we can then say, okay, you guys tell me what my spectator ions are.
Sodium, chlorine,
Yep. Those are my spectator ions. So what's the net ionic equation?
H plus HSO3 into the H2O liquid plus SO2 gas.
Perfect. That's it. Okay, so we're pretty much doing the same thing every time. The only difference is my product a solid? If it's a solid, we call it a precipitation reaction. If my product is just liquid water, we call it a neutralization reaction. And if my product is going to be gas or gas and water, we call it a gas evolution reaction. That's the only difference. So I have one more example to do. One more type of reaction to do. And then I have a bunch of examples to go through because I know you guys, this ends up being tough for you guys. And if I feel like if we do these examples, you're just doing the same thing over and over again. And once you do it like 5 times in a row, it starts to click. So.
One thing again, I have one.
Say it again.
Last you said like product is gas, it is gas evolutionary reaction.
Yep, so if it has, remember all a gas evolution reaction is saying is that it produces a gas. So anytime you have a gas as a product, we can call it a gas evolution reaction. Even if it has the liquid and the gas is still there, so we call it a gas evolution reaction.